Hello everyone, in this video I am going to explain how to perform amplitude modulation and then obtain instantaneous phase, instantaneous frequency and instantaneous amplitude of an amplitude modulated signal as well as frequency modulated signal. So first we'll perform the task for amplitude modulated signal. So here as we can see I've taken the sampling frequency to be 600 and then this is the time for which I'm taking the sinusoidal signals. Here x and y are the signals which are being modulated. X is the message signal and y is the carrier signal. So as we know, for amplitude modulation we just multiply carrier and message signal, and after getting the modulated signal, here AM is the modulated signals, and on that firstly we'll perform DFT to obtain results. So for computation of DFT I've used this. In DFT computation, as we know, the standard formula of DFT is sigma x of n into e to the power minus e 2 pi by n into n in k. Similarly, I've used the formula here, I've kept it in the loop here, and then after that I've obtained the magnitude response of DFT. And then after that, by using a standard practice Hilbert transform, I've taken the Hilbert transform here. These are the steps for Hilbert transform. After obtaining the Hilbert transform, we computed the IDFT for Hilbert transform to again get it in the time domain. And then after that, the Hilbert transform was Hilbert function was calculated directly using the MATLAB, the inbuilt function Hilbert. So after that, instantaneous amplitude of amplitude modulated signal is calculated here, which is nothing but the formula abs of z. It calculates the magnitude. So let us see the results. So here as we can see, this is the amplitude modulated signal. Here in the plot we have placed amplitude modulated signal which we have taken, and the Hilbert of the amplitude modulated signal are almost the same with just a time delay. And after that, for computation of instantaneous amplitude, this is the thing. Instantaneous amplitude is the blue line which we can see in the plot, and the red one is the amplitude modulated signal. In this way, amplitude modulated signals instantaneous amplitude can be obtained. Similarly, let us see how to obtain instantaneous phase and frequency for frequency modulated signal. The same steps has been followed here. Instead of in AM, we just directly multiply two signals. Here for getting FM modulated signal, I've used the inbuilt MATLAB command FM mod, where message signal I've taken, this is the message signal. 30 and 300 are the frequencies, and then the similar process has been used. DFT is computed, and then we take the transform of the function and then of the signal, and then Hilbert we generated the Hilbert signal using the inbuilt function. Here the thing extra which we are doing is calculation of instantaneous phase, which is nothing but angle of z, where z is the Hilbert of the FM modulated signal, and instantaneous frequency. For instantaneous frequency, this is the formula we've taken, and so let us see the plots for this. So this is the FM modulated signal as you can see. there are two different frequencies in the signal, and the instantaneous amplitude is always constant, which is 1. This red line indicates the instantaneous amplitude. And then after that, for instantaneous phase, we've taken this. This represents the instantaneous phase of the FM modulated signal. And then for instantaneous frequency, this is the plot for instantaneous frequency. This is how we get the instantaneous frequency. So that is all. Thank you.